It's Professor Dave. I want to tell you about the Pythagorean Theorem.
He knows a lot about all kinds of stuff. Professor Dave explains.
There is one more very important theorem we need to discuss regarding triangles. While some theorems seem pretty obvious, there is a theorem relating the side lengths of a right triangle that is not so obvious. This theorem is called the Pythagorean Theorem, named for Pythagoras himself, even though the theorem was likely discovered prior to ancient Greece. Nevertheless, it was an impressive feat of logic and one of the most famous mathematical relationships. So let's go over it now. In a right triangle, there is one 90-degree angle by definition. The two sides that meet to form this right triangle are called the legs of the triangle, and the third side, the one opposite the right angle, is called the hypotenuse. This theorem states that the sum of the squares of the legs of a right triangle is equal to the square of the hypotenuse. This is represented by the equation a squared plus b squared equals c squared, where a and b are the legs and c is the hypotenuse. This means that given any two sides of a right triangle, we can calculate the third. For example, let's say the legs have lengths of 5 and 12. We just plug these in as a and b, square them, and we get 25 plus 144, which is 169. Since this is equal to c squared, we have to take the square root of both sides. This gives us plus or minus 13 for c. Since this is not algebra but rather geometry and we are looking at shapes, we can throw away the negative value because it doesn't make sense for a side length to be negative. So we can definitively say that this hypotenuse has a length of 13. Likewise, we could know the hypotenuse and one leg and calculate the other leg. Say we have 5 and 9. That means 5 squared plus b squared equals 9 squared. 25 plus b squared equals 81. b squared equals 56, and b must be root 56, which can be simplified to root 4 times root 14, or 2 root 14. The lengths won't always be neat and tidy integers, so we'd better get used to this. Sometimes we do algebra using the Pythagorean theorem. Say the legs of a right triangle are equal to x and 4 root 3, while the hypotenuse is equal to 2x. What are all the side lengths? Well, we can plug these terms into the theorem just like we would any numbers. After squaring everything, on the left we have x squared plus 4 squared is 16 times root 3 squared, which is 3, giving us 48. On the right, 2x quantity squared is 4x squared. We subtract x squared, divide by 3, and take the square root. Once again, although we technically get plus and minus 4, negative 4 doesn't make any sense here, so x must be 4. That makes the missing sides 4 and 8. This theorem is incredibly useful and ubiquitous in math. So how is it derived? How can we know for sure that this relationship between the sides of a right triangle is true? A satisfactory proof will require the ability to calculate the area of certain shapes, so I promise we will return to this question very soon. For now, let's check comprehension. Thanks for watching, guys. Subscribe to my channel for more tutorials. Support me on Patreon so I can keep making content. And as always, feel free to email me, ProfessorDaveExplains@gmail.com.